Welcome to a session on vertical translation and phase shift. And this is pretty much the finished equation that we graph for sine as well as for cosine. So we have y equals k plus a times sine or cosine bx plus c, with k being the vertical shift, a being the coefficient, which means amplitude, and the only reason the absolute value bars are there is because it could be a minus in the front of it. And that would just mean that it's going to be reflected about the x-axis. The coefficient b, which is closely related to the period, so period equals 2 pi over b, or b equals 2 pi over the period. The coefficient c, which together with the other coefficient b here is closely related to the phase shift, as in phase shift equals negative c over b, or c equals negative b times the phase shift. Let's do a few examples, and what I'm going to have here is y equals 3 plus sine pi x. Let's see what happens. K, of course, is the vertical shift at 3. The amplitude is 2. It's not being reflected, so it's a normal sine. B, the coefficient b is pi, and then the p is calculated as 2 pi over b. 2 pi over b, with the b being pi. And that, of course, comes out to 2. So because the b is a multiple or a fraction of pi itself, we come up with the period being a nice integer or fraction itself. And we'll see that once we're graphing. Let's go over to the graphing calculator. Let's see, there it is. Okay, first of all, I'm going to check the mode that I'm in radians. I am. Then I'm going to plug in the equation. So this would be 3 plus 2 sine pi x. I'm going to look at the window setting. For the x minimum, I guess I could just call as a 0 here maybe. For the x maximum, maybe I go out to 2 pi. That will mean that I get a few periods. Remember that our period was 2, which means I'm going to get just a little bit over 3 full periods. Scale, I just leave at 1, and we'll see that it repeats after exactly 2 and after exactly 4 and so on. For the minimum, because the vertical shift is 3, by the way, in the meantime, you might be already able to see it down here. So the vertical shift is 3, and the amplitude is 2, so the minimum is going to be a 1, and the maximum is going to be a 5 for the curve. I still want to have the x-axis in there, so I'm going to call this negative 1 here, and this here might go up to 6. And then I graph, and there it is. There it repeats at exactly 2, it repeats at exactly 4, and it starts repeating at exactly 6. So there is this equation here with almost all the information in there. The only thing that's still missing is a phase shift, which we're going to do in the next couple of examples. One little note on the side, you'll see in the script that I'm talking about X-Intercepts. Sometimes the X-Intercepts help. And let me go back to here. In this case, actually it doesn't help because there are none. But if I go back to Word, and we're going to look at this. So sometimes they can help. For example, I have y equals negative 2 cosine x. Then I know that I have x-intercepts wherever the cosine is going to be 0, which will be at 90 degrees, and at 270 degrees, and at 450 degrees, and so on, respectively. Pi over 2, 3 pi over 2, 5 pi over 2, and so on. But in our case, of course, we didn't have any x-intercepts, because the crests, as I mentioned while graphing it, are 3 plus 2, and the troughs are 3 minus 2, which is the vertical shift, plus or minus the amplitude. So they don't touch or cross the x-axis. Okay, let's do another example. So graph y equals 3 sine 2x plus pi over 2. And this is how the graph looks like. It's a sine curve with an amplitude of 3. So absolute value bars, I think I'll put them in later once I find them again. What is the period? Well, since the coefficient b equals 2, the period is going to be 2 pi divided by 2. And I'm going to insert the pi there. So that's going to come out to simply pi for the period. So it's squeezed by a factor of 2. In which direction is the function shifted? Well, to the left. Actually, I'll do this here in a moment. I'll put it here. Because first, let's determine that c equals pi over 2. And then we have the phase shift is negative c over b. So we have minus pi over 2 divided by b, which is 2. So we're going to come up with negative pi over 4. And because of that negative, it's being shifted to the left. Notice that that phase shift, the formula for it has that extra negative inside, so that when you look at what's happening inside the sine itself, you have a plus pi over 2, but because of the extra minus there, that actually means it's being shifted to the left. And if it had a minus right here, then it would be shifted to the right. Again, because of that extra negative, which would cancel that hypothetical minus that you have here. You can quickly perhaps look at it, what the phase shift would be. The c coefficient c here is not going to be enough. You have to incorporate the coefficient b, and by quickly looking at it, you would say, okay, it's going to be pi over 2, divide by that 2, which is pi over 4, put a negative in front of it. But the formula is given right here. Okay, and that's where I just said, note that phase shift depends on the two coefficients, c and b. All right, what we're going to do now is I'm going to graph them point by point, and then after that we're going to go to the graphing calculator. So let's see. I want to grab it here. And I'm going to start out graphing a normal sine curve with an amplitude of 3. So I'm going to grab myself some points here, which I'm going to make red, I guess. Of course, the sine starts at 0. Then it's going to get up to 3 at pi over 2. Then back to 0 at pi. Negative 3 at 3 pi over 2. And back to 0 at 2 pi. Okay, now I'm going to look at that the whole graph is being squeezed by a factor of 2 with a period of just pi. That point over here will end up over there. And looking from a different direction means that we're squeezing the entire graph by 2. So I'm going to grab this one here from pi over 2. It's going to end up at pi over 4, which top of my head is close to 0.8. This one here ends up at pi over 2. This one ends up, well, somewhere over here. At this point I'm not actually calculating that one in my head. I'm just taking a very good guess here that that's where it's going to be, and this of course ends up at pi. Then we're going to look at the phase shift. And remember, the phase shift is pi over 4 to the left, so everything is going to go to the left by approximately 0.8. Of course, 3.14 divided by 4 is almost 0.8, so everything is going to shift over here by 0.8. That one actually ends up right on the y-axis. That one is going to be, I want to say, about here. Yep, that's very correct. And that one is going to be here. And that one is going to be here. And then I'm going to take a pen here, and I'm going to try to draw as good as I can. This may or may not turn out. maybe, well, sorry about that little kink there. Maybe I do have a little practice in the meantime, because I've done this lecture actually a few times before as I was recording it for previous trig class. Okay, so that's the graph of it. Let's go over to the graphing calculator and see that that is indeed correct. So here we have 3 sine 2x plus pi over 2. There we go. Going to look at the window. In this case, we have an amplitude of 3, so I may want to go down here to -4 to 4. There. And because I shifted it to the left, I may want to go with the x here to at least -1. And then I guess I could go out to 2 pi, even though I only went to pi. And I'm just going to go to 4 here itself. Okay, here we go. There, that's what I said. It would be at the maximum amplitude of 3, where on the y-axis, this point over here is being shifted to -pi over 4. Let's just check it. Oh, this might take a while because the dot is so far to the left. Guess I could have checked the x-intercept instead. Yep, -0.78, which is -pi over 4. That was the phase shift we had. In the meantime, looks like a cosine, but of course, remember that a sine can be easily made into a cosine. In fact, that's what the phase shift can do. Okay, we'll do another example. So I'm going to make the word. So what I wrote down here is explained during the eLive recording. A normal sine graph is sketched first, then squeezed by the factor 2 to half the period p equals pi, then shifted left by pi over 4, and finally a more or less smooth curve is drawn through the points. Okay, graph. 3 plus 5 sine pi x plus pi over 4. We have a vertical shift of 3. We have an amplitude of 5, which means we have the crests at 8 and the troughs at -2. The coefficient b is pi, which gives us a period of 2 pi divided by 2. I'll do that right here. 2 pi divided by 2. Grab a pi over here, which comes out to, oops, did I say 2 pi divided by pi? There we go. Which comes out to 2. We have coefficient c of pi over 4, and then, as I said earlier, phase shift is pi over 4 divided by the coefficient b, which is pi. So pi over 4 divided by pi, put a negative in front of that, the pi's cancel, and what survives is -1/4 or -0.25. So again, I'm going to sketch that first, and then use the graphing calculator. Okay, I'm going to take the next one. I squeezed the scale on the y-axis because we go out all the way up to 8, so I need the space here. I'm going to graph first one with a normal sine curve with an amplitude of 5. So it starts at 0, then we're going to be at 5 apparently here because of my new y scale. Then at pi we're back to 0. Then we're going to be down here at -5, and then we're over here at that one. Okay. I figure I'm going to squeeze it first here by a factor of pi, which means that this one here will end up at 1. So this one here will end up at 1, which means this one here will be in the middle at 0.5. This one here will end up at 2, and this one here will end up in the middle of at 1.5. I did these two here first because they were easier to look at, and then put the other one in there. Okay, now I'm going to shift it up by 3, so every point goes up by 3. There, there, and where does this one go? -2, right? 3 minus 5, yeah. Okay, and then everything goes over by -0.25, so just slightly over. This one slightly over to 0.25, slightly over, and slightly over. Okay, and then again I'm going to attempt a smooth curve through here. It's a really squeezed graph, so let's see how good I'm going to be. Not too bad, I believe. This is done with a mouse. Alright. Notice that the y-intercept is not as at a nice number, 7 point something, I'm guessing 7.7 or so. We'll check that in a moment on the graphing calculator. Okay, y equals. So here we have 3 plus 5 sine of pi x plus pi over 4, which gives us a phase shift of -0.25. And I believe I already see what it's doing. No, that's not the graph, that's the last graph. Because I squeezed it to 2, I'm going to look at the window here. Yeah, that'll work. That'll work if I put it out to 4. This one here should go all the way from -4 is okay, but this one here should go to 10. Let me see, I'm going to go back here that I didn't make a mistake. Looks like I did it correct, so I'm going to graph. And there we go. Yeah, it looks pretty high there, and there it is. And there you go. That pretty much looks like mine, except I did only part of it. I kind of started around here, went up, and came back to about here. I'm just curious what that y-intercept is. As I said, for my sketch, it should be about 7.7. Oh, stop. No, I clicked it way too often. No, 6.6, I guess. I had squeezed it so much that it was tough to draw right there and see where it crosses the y-axis. But in that neighborhood, definitely not a nice number. Okay, with that, I'm done with section 4.3. Just going to go back to my script here, where I put in that the normal sine graph is sketched first, and then I didn't shift it up by 3 right away, but I first squeezed it by pi. For example, the 0.2 pi became the 0.2 and so on. Then shifted left. I think that's what I did last. So I did this one here, and then shifted up by 3, then shifted left by 0.25, and then I put a smooth curve through it. And that's it for this section on vertical translation and phase shift.